In the previous session, we looked at graphs of linear equations or functions. Now we will look at graphs of quadratic equations. This is the simplest quadratic function. F of x equal to x square plus 0x, so we can actually ignore it. Its graph is a parabola. So what does a parabola look like? It looks like this. In general, the quadratic function is y is equal to f of x is equal to ax square plus bx plus c. It has three parts. Quadratic part, that is the ax square, the first term. Linear part, that is the bx. And the third is the constant c. Notice that changing a changes the shape of the parabola. Changing b moves the parabola. And changing c changes the y-intercept. So let's actually see. So we have the parabola, and these are the points used to plot this graph. Now let's change some values. As of now, the graph is for f of x equal to x square. So let's change the coefficient of x square, which as of now is 1. Let's change it to, or let's animate it so that it continuously changes. So do you notice the shape of the parabola is changing? Now changing b moves the parabola. So let's change b. So you notice changing b moves the parabola. Let's again go back to the starting point. And changing c changes the y-intercept. So the point at which it is crossing the y-axis or intersecting the y-axis is changing. The parabola intersects the x-axis. At no point when it is opening upwards and is entirely above the x-axis, it is opening downwards and is entirely below the x-axis. So when will it be? It is as of now opening upwards. Now let's take it up. To take it up, what do? We change the value of y-intercept, that is c. So it is not intersecting the x-axis. Now let's make the coefficient itself of x square negative so that it opens downwards. And let's change c to -2, let's say. So again, in this case also, it is not intersecting the x-axis. It will intersect it at one point if it touches the x-axis. So when will it touch the x-axis? When c is equal to 0, whether it is opening upwards or downwards. And at 2 points, if it is there on both sides of the axis. So let's take c to 1 now. No, not 1, to -1. So at 2 points. Similarly, if it is facing downwards and c is 1, then also it is intersecting at 2 points. A is equal to 0. That is, the coefficient of x square, if it is 0, then what happens? The function becomes a linear function. So let me actually put some values there so that we can see it. Okay, x square plus x plus 2. So as of now, it is quadratic. But if we make a equal to 0, it becomes a linear. So ax square disappears and we are left with x plus 2, which means it is linear. When a is not equal to 0, but b is equal to 0, so let's make b equal to 0 and c also equal to 0. It is called pure quadratic because only the term with degree 2 is only there. In that case, it is called pure quadratic. When A and B are not equal to 0, so let's make B equal to 1. It is called affected quadratic. Now, discrete graph, we don't join the points. So this is discrete graph of x square plus x. Continuous graph, the points are joined to form a continuous curve. The more points we plot, the smoother the graph. Because as of now, we have only this many points. So if we join it using straight lines, right, it will not be a proper quadratic curve. So we need to get more and more and more points. So the more points we plot, the smoother the graph becomes. Now, the values of A, B, C are treated as parameters. Once chosen, they remain fixed for a given graph, while x varies. Now, in case of a linear function, we get a straight line, and the slope of a straight line is constant. It is the same throughout its domain. Here, it is much more difficult because by looking at this graph itself, we know that the slope is not going to be same throughout. So to figure out the slope at a given point, we take a point and we draw a tangent through that point, tangent to the curve. So notice this tangent line is changing. That is, its slope is changing. That means the slope of the quadratic curve is changing at different points on the curve. So the slope of the quadratic curve at a point a comma f of a can be evaluated by drawing a tangent at that point. Then the slope of the curve is equal to the slope of the tangent. And a straight line, remember, has a constant slope throughout its domain. A nonlinear curve has a varying slope over its domain. So that was graphs of quadratic equations or functions. That's it for now.